As 2020 draws to a close, I've been reflecting on some of the key megatrends that I've observed this year. Three of them stand out to me. The obvious one, of course, is how enterprises have embraced remote working. Teams and Zooms have obviously benefited from this, as have other real-time collaboration tools like Mural and Miraboard. The second big megatrend I've observed this year is hyper-automation. And by hyper-automation, I mean, how do you take the benefits of robotic process automation and bring it to the desktop of every employee in an organization so that they can focus on what is important and automate the mundane. Originally pioneered by UiPath, we've had lots of followers in the likes of Blue Prism, Automation Anywhere, and even Microsoft's Power Automate. The third megatrend I've observed this year is democratization and the rise of citizens. And it comes in three forms: democratization of application development, democratization of analytics, and democratization of AI and machine learning. Essentially, what this means is, how do we take every employee in the organization and turn them into a programmer, a BI developer, and a data scientist so that they are self-sufficient and not dependent on IT. Low-code platforms like Bubble.io, Mendix, Airtable, and Microsoft Power Apps helps users to build applications quicker than ever before. With tools like Power BI, Tableau, and Superset, anyone can build their own bespoke reports without having to depend on a BI developer. And finally, and most interestingly, with tools like KNIME, Azure's AutoML, and Exploratory.io, AI and ML has become far more accessible to users than ever before. I think this is a massive game changer. In the next 5 minutes, I would like to demonstrate how we could use an open source tool called KNIME and an open dataset from the US Supreme Court proceedings between 1946 and 2016 to predict the outcome of a case. Let's get started. So this is the KNIME interface. It can look a bit daunting, but you will get used to it very quickly. Over here you have the KNIME Explorer, which is where all your projects are. You have a workflow coach which suggests recommended nodes, and over here you have your node repository, which is a comprehensive list of nodes. So let's get started. Let's find our dataset. So our Supreme Court dataset is over here. As I mentioned earlier, what we are going to do is we are going to predict the outcome of a case. So this loads the data from a CSV file. As you can see, it has a bunch of different attributes. And it also has an attribute called party winning, this variable here. And as you can see, it can take a value of 1 or 0. 1 effectively means the party has won, and 0 means it has lost it. So let's get started. For our example today, we are going to use a algorithm called random forest. So the first thing we will use is a learner. So this one reads a bunch of input data along with the expected outcome and creates a model. Using that model, we are going to predict the outcome of a sample. In order to assess how effective our predictions are, we need to score the model. So we're going to search for a scorer. Cool. The next thing we need to do is get the data set and split it into two. one, a training set to train the model, and a validation set to test how well our model is. So we're going to search for a partition. So a partition splits the data set into two. So since we're using a random forest learner, I know that we need to convert all our numeric data into strings. So I'm going to search for that. And I also know that my random forest learner would benefit from a domain calculator. So a domain calculator, as it describes here, has a list of features and all possible values that feature can take in that data set. So our skeleton prediction model is ready now. Let's connect the data set. So we take our input file and connect it to the number to string, which converts all numbers into strings. We then connect it to the domain calculator, which calculates all possible values for our features in this particular data set. We then hook it to our partitioning module. So we're going to configure it to say 70% of it or 80% of it is we're going to use to train the model, and the remaining 20% to validate how well our model is performing. And we are going to randomly select which observations go into the training set and which goes into the validation set. We then connect our training data to the learner module, and we have to next configure our algorithm to predict the field we want. So as I mentioned earlier, the field we want to predict is the party winning. We then connect the model that we have just built to the predictor. We then take our validation set or test set and hook it to the predictor, and it's going to predict the value of the 20% that is our test set. So let's just quickly configure that. So it says the column name where the predictions are going to be stored is prediction and within brackets winning party. We can change that if we want to, but we're just going to. And finally, we're just going to hook our scorer to the predictor to see how well it has performed. So if I configure that, so the first column will be the party winning, and our second column will be the prediction party. So that's our first prediction model. Let's quickly execute it. So you can see converts from number to string, domain calculator gets done, partition gets done. The random forest learner is now reading the data and trying to come up with a model, and the predictor takes the remaining 20%. And as you can see, we have the output and over here the accuracy is about 97%. So that's a very quick introduction to KNIME and how you could use it. So here's one I prepared earlier, very similar to the previous one where we saw we had a random forest learner, we have a predictor and a scorer. But what we also have here is a bit of data preparation. So I've removed some of the outliers. I've removed any of the columns where we have more than 90% of the data is missing. Also here is a section to visualize why a particular prediction was made. In this example, we have taken one particular observation and we've tried to explain what are the attributes that resulted in that particular prediction. So let me quickly show you that. So as you can see here, there are a bunch of about 40-50 different attributes, and in this particular instance, the two attributes that really made a difference in this particular prediction is the Chief Justice, the docket, and the lower court disposition are the three biggest attributes that resulted in that particular decision. So hopefully you found this useful, and hopefully this inspires you to go out and see what insights are hidden in datasets that you have access to. Thank you for listening and look forward to your comments.